Hello. Hello.
यस सर, आवाज आ रही है।
Morning to all.
गुड मॉर्निंग सर।
Hello. Am I audible to all of you? Hello. Hello. हेलो, आवाज आ रही है सभी को?
यस सर।
Today we will discuss about the Bluetooth technology. In the previous lecture, we have discussed about the IEEE 802.11 that is based on wireless LAN system here, and now the next one is exactly we talk about the architecture we have discussed. Architecture contains basically two types of network. First one is an ad hoc based network and another is an infrastructure network. And another is also a type of extended service station. Means that is the wideband type network. In this particular ad hoc based network, there is no access point required. There is no access point that is connected to BSS. So access point is not there. Only BSS are connected. Clear? So, and in case of infrastructure BSS, we are having the BSS systems along with an access point. So all the BSS are connected with the access point and they can communicate the message or the packet through this particular access point. They all are connected with the centralized access point. Okay? In any wireless communication system, if you want to communicate from one BSS station to another BSS station, so access point is required. Clear? But in case of ad hoc network, it is not there. Now the another service is an extended service set. This is exactly used for large scale communication that is suppose one BSS in a network and you want to connect with the another network frame. Yeah. So the BSS from one station frame, one station network is connected with another station network or BSS through this access point. So it is called as extended service set. Now you can see the upper diagram is for the distributed size system having several BSS stations along with the access points connected to them, and there is a centralized router, a centralized system where all the access points are connected, clear, and there is a server or gateway through which the packet transmission takes place. So this is the type of extended service set where we have a group of BSS stations uh, in a particular domain in a particular area, and we can make them access with the help of access point. Now there is a three type of mobility system. First one is no transition mobility, another one is the BSS transition mobility, another and third one is the ESS transition mobility. In no transition mobility, either station or either station और मूविंग ओनली इनसाइड ए बीएसएस, मींस कोई भी स्टेशन आपका बीएसएस स्टेशन के अंदर ही मूव कर सकता है, उसके बाहर मूव नहीं कर सकता. क्लियर? In BSS transition mobility, it can move from one BSS to another BSS. एक BSS से दूसरे BSS के तरफ मूव कर सकते हैं. In case of ESS transition mobility, it can move from one ESS to another ESS. This is a wide band network. Now, the next one is max sublayer, which we have covered in the previous lecture. It is having two type of coordinate function, that is distributed coordination function, and second one is PCF. PCF is what point coordination function. And if we talk about distributed coordination function, it is having the frame it is having exactly the IEEE max sub layer. This is the IEEE max sub layer system which uses the CSMA protocol, that is collision avoidance protocol. We all have discussed about the how the communication takes place in this particular scheme. Suppose I am again repeating. The upper portion is the MAC layer in IEEE 802.11 standard, which is having the LLC sublayer, that is logical link control sublayer, and the MAC sublayer, which is having PCF and DCF, and the upper part contains the data link layer portion, and the lower portion contains the physical layer, which is having FHSS, DSSS, infrared, OFDM, and so on. Clear? Now, if we talk about the frame transmission in case of this particular scheme, DCF, distributed coordination function. So you have a source A, destination B, C and D. Clear? C and D are the other stations, and A and B are having participate in the transmission. So if suppose A transmit a request to send a request to send to destination B, then it is wait for a particular time, that is called DIFS. DIFS is exactly known as distributed. DIFS is what? The distributed interframe space. Yeah, it is the time before sending the RTS message. It is the time to wait for the source station A before sending the RTS station. Exactly, wait for a time duration and sense the channel that it is idle or not. So in sensing the channel, it waits for the distributed frame space time. Clear? And then send the RTS request, and this RTS request goes to the destination B, which again having a wait time, that is SIFS. SIFS stands for short interframe space. It is again a time where the station B waits uh, for sending the CTS request, CTS message to source station. CTS is clear to send. This destination address tells that the path is clear, so you can now send the message. Clear? So in that case, when the path is clear and the destination is free, then the source station again wait for SIF. Source station again waits for this particular sort interframe space and send the data to the station B. That is the destination is there, station, and then the destination station again wait for this SIFS short duration space time, and then send the acknowledgement. Acknowledgement is received to the source station. It means the package transmission is successful. Yeah. So this is the distributed type coordination system. Now the next one is these are some terminology that is used, that is network allocation vector. Network allocation vector is a vector which is the wait time for other station. Exactly. This is the time allotted to the other stations, those who are not included in the transmission. If someone is transmitting there, so they wait for a time to which the transmission of the other station gets completed, and after that they can send the packet or message to the sender. This is exactly the wait time allocated to other stations, those who are not participating in the transmission when another station is sending their data into the channel. Where that is called NAV or network allocation vector. And after that, another distribution system is the point coordination function. It is exactly a type of system where the communication takes place uh, in a contention-free polling access method. It uses a contention-free polling access method uh, where the AP performs polling for a station that are capable of being polled. The station are pulled one after another, sending any data they have to the access point. So this is the diagram for the this particular scheme. You can see the polled station is used. This is the polled station. It is used, and the other stations are in the bottom side. There is a NAV. NAV I have already told you. This is the wait time for the other station. Those who are not sending their frame or data at this time. So B is called the beacon frame. You all know B is the beacon frame. Now this is the frame format. This is the frame format for the this particular standard. This is the max sublayer frame format in which we are having two layers. First one is this and another is this. Clear? We are having two layers. First one contains FCD, address 1, address 2, address 3, address 4, SC, frame body, FCS. The second sublayer consists of the protocol version, type, subtype, 2DS, from DS, more flag, and retry, power management, more data, web, and reserved. The upper layer is the bytes information and the lower one is the bits information. Now these all I have already discussed, so I'm not going to the detail of that again. So these all things have been discussed. Various type of IEEE 802.1b standards such as 802.11a, 802.11b, 802.11g, 802.11n, These are the standards here, and all the details are given over here, which we have already discussed. Now we come to the Bluetooth system. Here, my voice is clear to all of you.
Yes, sir.
Now we come to the Bluetooth system. Bluetooth is a wireless LAN technology. It is designed to connect devices at different functions, such as telephones, notebook computer, cameras, printers, and even of so many other places where we are using the short distance communication in a personal area network. So we just utilize the Bluetooth system. The Bluetooth LAN can connect to the internet if one of the gadgets has this capability. It can also communicate with the internet if one of the gadget have this capability. A Bluetooth LAN may be by nature it cannot be large. If there are many gadgets and try to connect, this technology has several applications such that peripheral devices such as wireless mouse, keyboard. You all know about that. They are connected with the Bluetooth technology. Their monitoring device can communicate with sensor device in a small health care center. And so many other applications are there. It is basically originally started as a project by the Ericsson company. It is just started as a project when the Bluetooth is evolved by the Ericsson company, and the King of Denmark in 1940 to 1981, who united Denmark and Norway. Yeah. So today, this is a type of PAN network with 802.15 standard. 802.16 is for WiMAX and it is for the Bluetooth standard. Clear? Architecture, if we talk about the architecture, so it is defines two type of network, piconet and scatternet. Piconet exactly a Bluetooth network which is having a small networking. Here, it can have up to 8 stations. Maximum 8 stations are allocated, in which one of them works as a primary station and rest of them are working as a secondary station. Clear? Out of 8, one will be primary and 7 will be secondary. Clear? And all the coordination will be done by the primary station. Means no secondary station can directly communicate to primary. Means primary will control the secondary station. Clear? So it have only one primary station. The communication at the secondary stations can be one-to-one or one-to-many in a piconet network. A piconet can have a maximum of 7 secondaries. Additional secondaries can be in the parked state. अगर कोई आपका additional secondary है तो उसको parked state में डालते हैं. That is means that are type of steady state system. Clear? A secondary is a parked state is synchronized with the primary. जो हमारा सेकेंडरी से जितने भी हमारे स्टेशन होते हैं वो सिंक्रोनाइज होते हैं विद द प्राइमरी बट कैन नॉट टेक पार्ट इन द कम्युनिकेशन until it is moved from the parked state to the active state. कोई भी another हमारे पास अगर सेकेंडरी स्टेशन है beyond this, so वो सिंक्रोनाइज तो रहेगा स्टेशन ए से जो कि सेंट्रलाइज स्टेशन है पिकोनेट नेटवर्क में, लेकिन वो तब तक कम्युनिकेशन नहीं कर पाएगा जब तक वो एक्टिव नेटवर्क के अंदर नहीं आएगा. ठीक है? This is the type of piconet system. You can see the diagram. This is the diagram of the piconet system. Here is a primary system and other are the secondary system. This can communicate with the primary system. Now, if I talk about the scatternet network, that is the another category of this Bluetooth system. And in this particular scatternet network, a stationary station is one piconet, can be the primary in another piconet. It means जो सेकेंडरी स्टेशन होगा एक पिकोनेट के अंदर, जैसे मान लीजिए ये हमारा 1 पिकोनेट है, इसमें एक स्टेशनरी स्टेशन है, it will deal as a primary station to the another piconet system. This is the another piconet system. This is the another piconet system. This is the first one and this is the second one. In the second one, you can see the secondary station. If goes to the secondary network, piconet network, it will behave as a primary network. तो पहले वाले में यही वाला जो नेटवर्क ये आपको दिख रहा होगा, मैं डायग्राम पूरा क्लियर कर देता हूँ। स्कैटर्ड का मतलब ये है कि जो हमारा अदर नेटवर्क में भी कम्युनिकेशन पॉसिबल हो पाए, जैसे यहाँ सेम नेटवर्क में कम्युनिकेशन हो रहा है या अदर नेटवर्क में भी वो पार्टिसिपेट कर रहा है कम्युनिकेशन। तो दिस इज वन नेटवर्क एंड दिस इज अनदर नेटवर्क। यहाँ पहले वाले नेटवर्क में जो हमारा सेकेंडरी है वो दूसरे वाले नेटवर्क में एज ए प्राइमरी काम कर रहा है। दिस इज वर्किंग एज ए प्राइमरी एंड अदर आर द सेकेंडरी इन द सेकेंड नेटवर्क, सो इट कैन कम्युनिकेट। My voice is clear now, everyone? Hello?
Yes, sir.
Okay. So now if we talk about the Bluetooth layers, this is very important. So we have discussed exactly the two types of system, that is piconet network in Bluetooth and scatternet network. Now if we talk about the Bluetooth layers, so Bluetooth exactly uses several layers that do not exactly match those of the internet model. So the first layer is the L2 cap. This is very important layer. This is asked several times in the paper. What do you understand by the L2 cap? This is the logical link control and adaptation protocol. L2 means logical link. We are having the logical as well as link. So if you are having the two terminology starting from the L letter, so we are having L2 there. So logical link control and adaptation protocol. Here, this is called L2CP. L2CAP is roughly equivalent to the LLC sublayer in LANs. It is used for data exchange on ACL link. Okay? SEO channel do not use L2 cap. The SEO channel does not use the L2 cap. So you can see the architecture. This is the Bluetooth layer having type of frame structure like that. There is a baseband layer, this is the radio layer, and this is the L2 cap layer there. So these are the different type of Bluetooth layers structure. Now if we talk about the data frame format of this, it is important. If we talk about the data frame format of this, so it contains 2 bytes of length field, 2 bytes of channel ID, and 0 to 65,535 bytes data and controls field. Clear? So it is having exactly the 3 fields of different lengths. So the 16-bit length field define the size of data. तो 16-bit length जो है 2 byte means हो गया आपका 16-bit, which is define the size of the data. It is coming from the upper layer. Data can be up to 65,535 bytes. The channel ID defines a unique identifier for the virtual channel created at this level. So this is exactly the L2 cap data packet format. Here, now we talk about the multiplexing. The L2 cap can do multiplexing at the sender side. It accepts data from one of the upper layer protocol frame, then and delivers them to the baseband layer. At the receiver side, it accepts a frame from the baseband layer, extract the data, and deliver them to the appropriate protocol layer. Now the next one is the segmentation and reassembly. Here, so the maximum size of the payload field in the baseband layer is 2774 bits or 343 bytes. So this includes 4 bytes to define the packet and packet length. Therefore, the size of the packet that can arrive from an upper layer can only be 339 bytes. Here, now if we talk about the quality of service, so Bluetooth allows the station to define a quality of service level. All of you are requested kindly mute your. Okay, so now there is again so we have another group management system. Kindly mute your mic. हेलो आवाज आ रही है हेलो
Yes, sir.
kindly mute yourself in between the lecture. So group management and is the another functionality of L2 CAP system which allows device to create a type of logical addressing between themselves. This is similar to multicasting. So another functionality of this L2 CAP system is the group management, which is used to create a type of logical addressing between themselves. Now the next one is the baseband layer. So the baseband layer is roughly equivalent to the max sub layer in a LAN system. The access method is TDMA. The primary and secondary station communicate with each other using time slots. Here, the length of the time slot is exactly the same as the well time, that is 625 microsecond. Here, now the next one is TDMA. So Bluetooth uses a form of TDMA that is called TDD TDMA, means time division duplex TDMA. It is a kind of hop duplex communication where the hop duplex system. However, the communication for each direction uses different hops. This is similar to walkie-talkie system, which uses different carrier frequencies. So, if we talk about the L2 CAP system on Bluetooth, it uses the time division duplex method TDMA scheme. Clear? Now, how the communication takes place in single secondary communication. So you can see this is the communication. If a piconet has only one secondary, the TDMA operation is very simple. This time is divided into slots of 620 microsecond. The total time is divided into uh, 620 microsecond. The primary uses even number of slots such that 0, 2 and 4. The secondary uses odd number of slots, means 1, 3, 5. So this is the primary and this is the secondary. So secondary uses the slot 1, 2, 3. So 1, 3 and 5. So you can see the packets are only in the 1, 3 एंड 5 मींस ऑड नंबर में हमारे पैकेट होंगे सेकेंडरी स्लॉट्स में, सेकेंडरी के लिए। प्राइमरी यूजेज आपका इवन स्लॉट, सो इट विल अपीयर इन 0, 0, 2, 4 and 6 and 8 here. So in slot 0 the primary sends the secondary receiver in slot 1 here. The secondary sends and primary receive. पहले स्लॉट में क्या होता है, प्राइमरी जो है सेकेंडरी को सेंड करता है और दूसरे स्लॉट में सेकेंडरी प्राइमरी को सेंड करता है। क्लियर? ये साइकिल आपके रिपीट होती रहती है। जैसे देखिए यहाँ से सेंड करेगा प्राइमरी सेकेंडरी को पहले स्लॉट में, इस सेकंड स्लॉट में सेकेंडरी प्राइमरी को भेजेगा, फिर से प्राइमरी सेकेंडरी को, फिर सेकेंडरी प्राइमरी को। तो इस तरीके से कम्युनिकेशन चलता रहता है। दिस इज ए टाइप ऑफ सिंगल सेकेंडरी कम्युनिकेशन, मींस एक बार में एक ही कम्युनिकेट कर रहा है। प्राइमरी भेज रहा तो प्राइमरी भेज रहा, सेकेंडरी भेज रहा तो सेकेंडरी भेज रहा, दोनों साइमल्टेनियसली नहीं भेज रहे। तो दिस इज अ टाइप ऑफ टाइम डिवीजन रिफ्लेक्स सिस्टम। Now, another one is multiple secondary communication. In this scheme, exactly multiple station can simultaneously access. There are more than one secondary in the piconet involved in the communication. Primary uses the even number slot and secondary uses the odd number slot. Okay. So you can see this is the primary. These are the multiple secondary stations, station 1 and station 2. All are accessing in the different time slot. The primary will send the packet or data in the event slot and the secondary will send the packet in the odd slot. So you can see the primary is sending, they are hopping the station in the event slot. So it is sending their data to here. Suppose secondary station 1 have the data to send to the primary. So it will send the data to the primary in the odd number of slot, odd slot. Again, the primary will send the data to the secondary station 2 and the secondary station 2 will respond in the odd number slot to the primary station. This is a type of multiple secondary communication. I think is it clear to all of you? Is it clear to all of you? Hello? Is this diagram is clear to all of you? Hello? Can we move to next? Okay. So if we talk about the links, two types of link can be created between a primary and secondary. Basically दो तरीके का link create होता है primary और secondary के बीच में. The first one is the SCO link and another is the ACL link. Here, so SCO is a synchronous connected oriented network link. It is used when avoiding latency, that is data in data delay in data delivery, which is more important than the integrity. This is a type of error-free delivery. In the SEO link, a physical link is created between primary and secondary by reserving specific slots at regular interval. A physical link create हो जाएगा. If a packet is damaged, it is never retransmitted. Clear? इसमें अगर पैकेट डैमेज होगा तो दोबारा ट्रांसफर नहीं होगा. It is the real-time audio where avoiding delay is all important. The secondary can create up to 3 SEO links with the primary. जो भी secondary station है वो 3 links create कर सकते हैं primary के साथ communication. Now the next one is the ACL, that is asynchronous connectionless link, which is used when data integrity is important. Clear? So मेरी आवाज आ रही है सभी को? हेलो।
Yes, sir.
All of you kindly hello. So now, so this is the now if we talk about the asynchronous connection link, it is used when data integrity is more important than avoiding latency. जब आपका डेटा जो है इंटीग्रिटी मतलब होता है उसकी सिक्योरिटी इज वेरी इंपॉर्टेंट, वो डेटा लॉस ना होने पाए देन एनी टाइप ऑफ लॉस, सो अवॉइड, सो इस केस में हम लोग क्या करते हैं, एसिंक्रोनस कनेक्शन लेस लिंक यूज करते हैं. नाउ दिस इज द फ्रेम टाइप फॉर्मेट, फ्रेम फॉर्मेट है ये, देख सकते हैं. It is having 72 bit of access code, 54 bits of header, ठीक, and 0 to n bits of payload, and then the sublayer consists of 3 bits of address information, 4 bits of type, then FAS, then in the last, that is सबकी working यहाँ पे आपको दी हुई है, all is given here, all the functionalities are given for the particular frame structure for the Bluetooth system. Clear? Now these are the, there is some modulation techniques given, FHSS and so other things. So now it is over. So now it is over. सभी को समझ में आ गया ये? हेलो, सभी को समझ में आ गया? Someone have any doubt, then they can ask regarding 802.11 and the Bluetooth system.